There's approximately 30 questions on the final exam. There's a test question pool, which has all the questions. I don't know, there's about 40 questions in there. The test question pool will give you'll do this at your normal, we'll do this at Harrison in the computer lab, and it will take 30 questions from a pool of questions. These come from the ASA questions for wood, fabric, finishes, and composites. I'm going to focus this time for the final. We're going to focus on looking at the composite questions because you already did a midterm review and you can go back and look at that section here in Blackboard. The final will be given during your normal scheduled day at Harrison. So let's start at the beginning with composites. And I'm only going to mainly go over what you need to know, what the major takeaways are, what you need to know for the final exam. So this is a picture out of the book. The important things on here is you need to know what roving is. And if you look here, roving is a single group of filament or fiber ends. This is composed of 20 or 60 strands. But you need to know the definition of roving is a group of filaments. They're not twisted. It's not like cable. They're straight. And so when you look in a fiberglass mat and you look at the weave, the roving is a grouping of filament. You also need to know that there's a couple of different types of cloth or mat. There are bidirectional and unidirectional. Okay, the bidirectional means that the load-carrying rovings are at 90 degrees to each other. Okay, that's bidirectional. The unidirectional doesn't really look unidirectional to me, but the strands are all in one direction. And so these have bidirectional, I think, is the most common that we use. That's what I use most of the time, but occasionally we do need to use uni. And uni, all our strands are in a straight line. And it says that it's equal properties is obviously what this says. Now, what is a warp clock? Okay, so warp is the direction of the longitudinal fibers, right? Warp, W-A-R-P. Warp is the direction of the longitudinal fibers. Now, if you look at this picture here, it shows that they've laid this glass mat like this, and then at another angle, and another angle, another angle. And that is to make the different layers carry loads in different directions. All right, so what they've done is lined up the longitudinal fibers, they've rotated them as we go layer over layer over layer. This is a multiple layer layup. A warp clock is this illustration that they show here in figure 3. You need to know that that's a warp clock. But so we need to know warp, we need to know roving, and we need to know bidirectional and unidirectional when it comes to the material properties. So next we're going to move on to epoxies. This is the epoxy that we used in class. This is an epoxy resin, and this is West system. There's a whole bunch of different types of systems. Now, West isn't normally used in aircraft. It's used in some, but not to much of a degree. There's a whole bunch of different brand names. But here's what we need to know about resins. These resins we're using are thermosetting resins. Now, this is a whole family of resins. There's polyester and vinyl, and that's what you can buy at the auto parts store. So the polyester and vinyl are the most common, but they are not used. They're definitely not used in aircraft. Aircraft mostly uses this epoxy polyamides, PBI and BMI type of resins. So here's what you really need to know. First off, thermosetting. The word thermosetting means that this will set or this will harden using temperature. Okay, so the word thermosetting is a type of action, specifically a resin type of action. Okay, you need to know that. You also need to know, most common is probably epoxy resin, is a thermosetting type of resin. Now, thermoplastic, different word. You need to know the difference between these two, and you need to know it for this test. Thermoplastic is a material. Okay, so thermosetting, we talked about resins, and that is how it sets, how the chemical reaction that hardens this. Thermosetting refers to curing of the resin. Thermoplastic, that's a type of plastic. Okay, now thermoplastic is something you could heat up and cool down. So acrylic window, you can take a heat gun, you can heat it, bend it, let it cool down, heat it again, bend it, right? That is a thermoplastic. Now let's go back to thermosetting. This is as it refers to setting, and the three stages. There's A, B, and C stage. So A stage, you need to know this. A stage is when the components of the resin have been mixed, but they've been mixed together. It's all liquid. Okay, nothing's happened yet. We've got a bunch of liquid all thrown in together. That's the A stage. The B stage is when it starts to have a chemical reaction. And the way we know this is it starts to get tacky. All right. Now, it might also warm up. Sometimes you can feel a little bit of heat. You can feel this liquid. If you got it in a cup in your hand, you can feel this stuff get warm, or you might even see smoke. That usually means we've got the wrong amount of mixture there. But that is a chemical reaction. That's actually the thermosetting of the resin. Okay. So that's the B stage. And then C is it's hard. We came in the next day, it's hard, it's fully cured. That is the C stage. So there's some questions about the three stages of resins. Okay, now we're going to move on to the types of fiber. All right, and fiberglass is one type of fiber. That's a fiber mat. We also had Kevlar, and Kevlar is used in aircraft. It's used, GE uses it on their jet engines for containment purposes if they have an engine failure and it throws parts. This is like a bulletproof vest for the airplane. Bulletproof vests are made out of carbon, Kevlar. Now, Kevlar is a lighter colored material. We'll show you a picture here. Carbon and graphite. They make a fiber of that, the carbon fiber that we talk about. And then there's some others. I don't get too, we won't see much of this, but there's some other types of fiber that are used. Here's the three main that you need to know what they are and what they look like. The fiberglass, that's what we used in class. Okay, and then Kevlar has this kind of a light color to it. And then carbon fiber is this really dark fiber. You need to know that. You need to be able to tell the difference between these. Okay, when we go to the fiberglass, there's two types of fiberglass. There's E-glass, and E means electrical. It's used for electrical applications. It has a high resistance to current flow. Then there's one more type, and that type is called S-glass, and that is structural. S means structural or strong, strength. Okay, those are two different types of fiberglass, and you have what I call normal fiberglass, and then you have E-glass